Good morning students, welcome to today's session. I think every one of you understood what not we have seen in the last classes under the topic polynomial. The last classes we have seen about the general form of a polynomial and what is the structure of the polynomial and the classification of the polynomial and what is degree of the polynomial and according to the terms how can we classify the polynomials and some examples also. And I hope every one of you understood all the concepts in that. And today also we are going to continue the same lesson. So before going to today's session, let us recall that all the basic definitions and concepts, everything, whatever we have seen in the last class. So the topic polynomial, so there is a general form of a polynomial. So here, so there is a general form of a polynomial. And the polynomial is an expression and which having one of the side as the function with respect to the variable. Okay. And in the last class we have seen what is the difference between equation and also polynomial. An expression which is equal to any other constant means that is known as equation, and an expression which is equal to any function like that p of x, q of x, or p of y, q of y, g of y. Everything is there. Okay, so that kind of expression everything is known as a polynomials, right? So here that this one also an expression only, and this one represented by the variable x only here, so that it is denoted by p of x, right? Suppose here in this expression the variable y is involving, then we can denote this function as p of y. So according to the variable, the function denoted by the different variables. Okay. And how can we check whether the given expression is a polynomial or not? In the last class I have said that it is enough to check the power of the variable. If the power of the variable everything it is in the form of a whole number, then it is said to be a polynomial. So otherwise not. So it is enough to check the power of the variable is a whole number or not for checking whether the given expression is a polynomial or not. Right, so let us recall the definition first, the degree of the polynomial. How can we find out the degree of the polynomial and what is the degree of the polynomial? So degree of the polynomial is nothing but the highest power of the variable in the polynomial is known as the degree of the polynomial. Right, so first we have to check whether the given expression is a polynomial or not by showing that all the power of the variable is a whole number or not, and then next we have to check what is the degree of the polynomial. So, among the power of the variables in the polynomial, the maximum value is nothing but the degree of the particular polynomial, right? And then next classification of the polynomial. So, how can we classify the polynomials? So, two varieties are there. One is according to the terms, and another one according to the degree. Okay. So, according to the terms, how can we classify the polynomials? If the polynomial having the term only one term means then it is said to be monomial. And in the polynomial two terms are there means it is said to be binomial. And the polynomial three terms are there means it is said to be trinomial. And in the polynomial four or more terms are there, then it is said to be polynomial alone. Okay, so that is a classification of the polynomial according to the terms. Okay, so according to the degree, how can we classify the polynomials? Okay, look at the flow chart. So types of the polynomial, this one according to the degree. Okay, so how can we find out the degree of the polynomial? Variable having the power 1, then it is said to be degree 1. Okay, the maximum power. And so here, which polynomials and all said to be constant polynomial. So if degree of the polynomial is 0, then it is said to be constant polynomial. So which polynomial are having degree 0? So it is represented by the constant alone. For example, p of x equal to 2. So it is also polynomial, but here variable is not attached here. Okay, even though it is a polynomial, here constant only available. Therefore, we can call this as constant polynomial. Okay, and it has the degree 0 only because the variable is absent here. So that's why. And similarly, the polynomial is to be linear if it has a degree 1. Okay, so look at the examples here. So x plus 2, y plus 5 and 3u plus 4. So everything having the maximum power 1 only in the variable, in the power of the variable. Therefore, it is these examples, everything comes under linear polynomial. And when a polynomial is to be called quadratic polynomial, the power of the variable is maximum 2, then it is said to be quadratic polynomial. So look at these examples here. So power of the variable is maximum power of the variable is 2, and similarly here also 2, and here also 2. Therefore, it is said these examples comes under quadratic polynomial. Next, cubic polynomial. The maximum power of the variable in the polynomial is 3. Then it is said to be cubic polynomial. So here 3, and here also 3 is given here. Therefore, this examples everything comes under cubic polynomial, right? So that is a classification of the polynomial under degree. Okay. So let us enter into today's session now. So next definition is 0 of the polynomial. So what is the 0 of the polynomial? Okay, look at the definition here. A real number a is said to be 0 of a polynomial p of x if p of a equal to 0. Right? So what is real number? So already you have seen in the first chapter about real number. So real number is nothing but it is a combination of rational and also irrational number. Okay. So if a is any real number, that is a is any form of the number, either root number or non-root number, whatever it is, or plus number, minus number, or fraction, whatever it is. Okay. So inside of x, if you replace this value, if the value of the polynomial will become 0, then the particular real number is to be 0 of the polynomial. Okay. So look at the example now. So p of x equal to x plus 3. So it is a polynomial or not first? Yes, it is a polynomial. What is the degree of the polynomial? So degree of the polynomial is 1. And according to the term, it is called a binomial. Okay. Now we are going to find out what is the 0 of the polynomial. Okay. And we are going to define which one is 0 of the polynomial here. Okay. So look at the next stage. If we replace x equal to minus 3, what will happen? So p of minus 3 equal to, instead of x, put minus 3 here. So minus 3, okay, instead of x, so minus 3 plus 3 already is there. If you add these two, so plus 3 minus 3 get cancelled, the answer will be 0, right? So if you replace a number, okay, inside of x, the value becomes 0, then the number, okay, the particular number which one we have replaced instead of x, this is known as 0 of the polynomial. So here minus 3 is the 0 of the polynomial p of x. Okay, I think everyone understood what is 0 of the polynomial here. Okay, so let us next example. See next example. So here p of x equal to x minus 2. So here which number you have to replace instead of x, you will get 0 as a value 2 only. So instead of x equal to 2, so 2 minus 2 will become 0. Therefore here 2 is the 0 of the polynomial. And what about the next one? Here x plus 4 is a polynomial. So instead of x, if you replace minus 4, this will become 0. Therefore minus 4 is the 0 of the polynomial. And similarly, so in this polynomial p of x equal to x plus 3, so instead of x, if you replace minus 1 by 3, we get 0. Therefore these numbers, everything, the zeros of the corresponding polynomials, given polynomials. Okay, so that is the procedure to find out the 0 of the polynomial. Okay, look at the next example. So find the 0 of the polynomial. So p of x equal to x plus 5 given here, we are going to find the 0 of the polynomial here. So we know what is 0 of the polynomial and which end are called the 0 of the polynomial. Okay, so here we are going to find out the 0 of the polynomial. How can you find out the 0 of the given polynomial? So this is the procedure here. To find the 0 of the polynomial, you put p of x equal to 0 first and then find the x. Okay, so here p of x what? X plus 5. So p of x is 0 means x plus 5 equal to 0. And then next we have to solve this equation. That's it. Okay, so how can we solve? So bring it 5 left hand side, right hand side, it will become minus 5. So now the value of x is nothing but minus 5. So therefore minus 5 is the 0 of this polynomial. So instead of solving this, if you replace x by minus 5, we'll get 0 as the value. Okay, therefore here minus 5, that is a procedure. Okay, that is a procedure. Here itself we can say which one 0 of the polynomial here. But with the proper procedure, here minus 5 is the 0 of the polynomial. Okay, and look at the next example. check whether minus 2 and 2 are the zeros of the polynomial x plus 2. Okay, now we are going to check that minus 2 and also 2 both are. Now we are going to check that minus 2 and also plus 2 both are the zeros of the polynomial p of x equal to x plus 2 or not. Okay, so look at the solution now. So let p of x equal to x plus 2. Okay, now we are going to check plus 2 and minus 2 are the zeros of p of x equal to x plus 2 or not. Okay, so that we are going to replace x equal to 2 first. Sorry, minus 2 first. So p of minus 2. So instead of x put minus 2. So p of minus 2 equal to. So instead of x minus 2 and plus and 2 equal to. So these two get cancel each other. The answer is 0. So what is the conclusion here? The value is 0. Therefore minus 2 is the 0 of the polynomial. Okay. So next, minus 2 is the 0 of x plus 2 already, that is minus 2 is 0 of the x plus 2, we have seen that. Now next we are going to check plus 2 is the 0 of the polynomial or not. Okay, so here I replace the x equal to 2 here, so p of 2 equal to, and instead of x 2 and then this 2 as it is, so 2 plus 2 4. So it is, the answer is 4, so it is not equal to 0. Therefore what is the conclusion here? 2 is not the 0 of the polynomial p of x equal to x plus 2. Okay, so the answer is 0 means the particular real number should be 0, otherwise not. Okay, look at the next example. So determine whether the given values of x are zeros of the given polynomial or not. Okay, so one polynomial is given here, right? So we are going to check this minus 1 and minus 5 are the zeros of the polynomial or not. As in the last example, what we have seen? We have seen 2 and minus 2 are the zeros of that particular polynomial or not by substituting the 2 and minus 2 instead of x. In a similar way, so here also we are going to replace x by minus 1 first and then minus 5 next, and then check whether it is the 0 or not. Okay. Now I took the first polynomial p, as p of x here. So p of x equal to x square plus 6x plus 5. Okay. So next I put x equal to minus 1 instead of x here. Okay. So instead of x, minus 1 whole square and 6 into minus 1. So plus 5. So next simplify this. So minus 1 square is nothing but 1. So how it is 1? We can multiply minus 1 2 times because of the power is 2 here. So minus 1 into minus 1 plus 1. And similarly plus into minus here, and then 6 into 1 6 plus 5, and simplify this. So 5 plus 1 6 minus second term also 6, so the answer is 6 minus 6 0. Okay, so what is the conclusion here? When we substitute minus 1 instead of x, we got 0 as the value. Therefore what is the conclusion? Minus 1 is the 0 of the polynomial. Okay, so next replace x equal to minus 5. Right, so minus 5 whole square, 6 into minus 5 plus 5 equal to, so minus 5 whole square, so multiply minus 5 2 times, so minus 5 into minus 5, so equal to 25, so 5 5s are 25, so 25, and then plus into minus here, and next 6 into 5 30, and this plus 5. Okay, now simplify this. So 25 plus 5 is 30, so 30 minus, so this 30, so 30 minus 30 equal to 0. Now what is the conclusion? The value is 0 now, therefore minus 5 is also the 0 of the given polynomial. So that is a procedure to check whether the given numbers are the 0 of the polynomial or not. Okay, by substituting directly instead of x and find the value. If it is 0 means they are the 0 of the polynomial, otherwise not. Okay, so let us continue from the next video.